Welcome to the 6th lecture in Module 2. In the last lecture we talked about distributed version control, and in this lecture we'll talk about Git, which is a distributed version control system that's very popular and widely used in the Rails community. This was the distributed version control system that was used to create the Linux operating system, and as I've mentioned, it's widely used by the Rails community as well. Git provides a means, as we've already discussed, for distributed version control of comparing the differences between the various versions of a project and stores them as snapshots and allows you to merge them accordingly. You should think of Git as forming a tree. The various versions form a tree, and the main branch is called master. And then you can branch off of master. You can create branches off of masters. It could be different versions. They can be, you can have different versions along the master branch, and you can also decide to create a branch off of that if you're looking at a new feature, things of that nature. People create branches for various reasons. A lot of times it's to investigate a new feature, and you try and build it and then merge it back into the master branch once you get it working. These branches, as I've already mentioned, can be merged back into the master branch. Let's talk a bit more about the basics associated with Git. Git tracks files that can reside in 3 different locations. You should think of your working directory. This is where you're editing and working with files, the staging area, and then the repository itself. In addition, the files in your working directory can be in one of 2 states. They're either being tracked by Git or they're not being tracked. And then finally, tracked files can be in one of 3 states. If you've edited a file, then it's considered, if you've edited a tracked file, I should say, then it's considered modified. If you haven't changed that file, it's considered unmodified. And then a modified file can also be staged. Let's look more at how this works. Here are the 3 directories that I just talked about: the working directory, the staging area, and the local Git repository. If you issue the command, and by the way, all of the commands I show there, you can put Git in front of them and execute them. So if you type git add and then dot, it takes everything in your working directory, assuming that you've got Git installed, and it moves those files into the staging area. Actually just notes them as being staged. They're not actually moved. And then if you perform a commit, that puts those files into your local Git repository. You can do this all in one step by saying commit-a, and then you don't have to do the add operation. Now, if you want to check out a particular branch, you just issue the checkout command, and you have to name the branch. And then you get all of the files associated with that version in your working directory, and you can get to work on them. If you'd like to merge 2 branches, you issue git merge and the branch name, and it'll merge that into the current branch that you're working on within your working directory. Next, let's see how you can install Git and get it working within your Rails application. So let's create a Git repository for our blog application. First, let's ensure that Git is installed on our system. If I type git, you'll see that there's a list of commands available to us. Next, let's cd to the blog directory, which is the root of the Rails application. This is where you want to create the Git repository. And we're going to use this command, the init command, to create an empty Git repository. And so if I type git init, it'll do that for me. Now, if I type ls-al for listing all of the files in this directory, you'll see that there's now a Git directory that was created. This is the Git database, and there's also a .gitignore file. These are the files that Git will ignore in your Rails application. What's interesting here is that Git was aware that this was a Rails application, and so if we take a look at that file, we'll see that it's ignoring your database files, temp files, and log files. In order to begin tracking the files in this directory, except for the ones that are going to be ignored, and to add them to the staging area, we type git add dot for all of the files in this directory. And now, if we type git status, we'll see that there now are a number of new files that Git is tracking. If we type git commit -m, in order to make our first commit, and the -m allows you to add a message on the command line. So I'm going to say that this is my initial commit for my message, it will go ahead and create our first commit. This moves these files into the local Git repository. Now if I type git status, it will tell me that I'm on the master branch and there's nothing to commit because I've committed all the files in this directory. It's not until I edit one of these files again that Git will tell me that I need to do another commit. So just to demonstrate that, let me pull the blog application up in an editor. And here I've opened the comment.rb file. And if I simply edit this file, and I'll then save it, now if I type git status again, we'll see that Git knows that that file was modified. And if I try to do another commit at this point, it will tell me that I can't do it at this point because that file is modified. I have to add that file by doing a git add dot. Now it's possible to do another commit. So there we have it. We've done 2 commits, and we see that Git is smart enough to understand whether or not a file has been modified and prevent me from saving that file to the Git repository until I've put it in the staging area. I should also mention that the last 2 commands can be combined into one by typing git commit -a and then -m and then the message you'd like to include with the commit. So this takes the place of the git add and the git commit. You can do them all on one line by using the -a command for this add. Next, let's look at the case when you have a remote repository. So now we've gone through how to add and commit versions within a local repository, but in many cases you want to push those changes up to a remote repository so that others can grab them and use them. The command to do this is called push. You push to the remote repository, and you have to specify which branch you'd like to push up to that remote repository. In order to retrieve a remote repository, you issue the fetch command, and then you have to check out a particular branch from that. So the fetch command brings that repository into your local repository, including all of the branches, and then you have to specify the branch you want to work on. Alternatively, you can issue this pull command, and this pull command does a fetch, and then it checks out the most recent branch and makes that your master. I also showed this clone step here. The clone step is used to create the repository initially on your system. You do that once, and afterwards you can simply use pull commands to pull the remote Git repository onto your machine. So next, let's look at how you can work with a remote Git repository. We're going to do that with Bitbucket. Now that we've seen how to work with remote Git repositories, let's create one. There are 2 very popular commercial sites for storing Git repositories remotely. One is called GitHub, and the other is Bitbucket, and we're going to use Bitbucket. So please go to bitbucket.org and create an account for yourself. And notice that this is a free account, and you should be aware that we're going to use Bitbucket in order for you to submit some of your homework assignments. Once you create that account, it'll take you to this page, and on this page, select the button that says Create Your First Repository. When you click that button, it'll take you to this page where you can fill in some information about this repository. So here I've said that the name of this repository is going to be blog because I'm going to store our blog repository, our blog application, I should say, remotely at this site. And I've given a description. I specify that this is a private repository, and I'm not going to allow others to fork this repository. I specified that it's a Git repository and that the language is Ruby. And after creating this repository, it takes me to this page. And here I select the link that says I have an existing project to push up. And when I select that link, it gives me some instructions on what I should do next. It says I need to go to the root of my Git repository. I need to add this as an origin, a remote origin, and then I need to push the application. So let's do that. Now let me show you how you can sync your local repository with this repository that's now on Bitbucket. I'm in the root directory for the blog application. This is the Rails root for this application. And recall that we previously set up a local Git repository in this directory. In addition, we've also set up a remote Git repository at Bitbucket. The next step is to link the two. And when we created the Bitbucket remote repository, it gave us this command to use in order to link the two. And here it's issuing the git command specifying that we want to add a remote repository. We're going to name that repository origin, and this is its location. So what this does is it creates a link between these two repositories. So when we hit return, the link is created. Now before I push my blog application up to Bitbucket, I need to configure Git a bit more. If you type git config -- and you can either use global if you want to set this configuration option globally, or locally if you want to restrict it to just this application, just the blog application. I recommend you do this globally, but I'm going to do it locally because I have other Git repositories where I use other names. So you say user.name and enter your name. Let's do the same for our email. And the reason we're doing this is whenever you do a commit to a remote repository, it stores who made the commit along with their email address. So let's go ahead and do the push to the remote repository. We type git push origin. This is where we want to push our repository, and the branch we want to push is master. It asks for our password, and this is your Bitbucket password, so let's enter it. And when we hit return, it's going to push this up to Bitbucket. And it's done that now, and we can check the Bitbucket site to see that it's actually up there. Just to ensure that everything is working as I've described, go back to the Bitbucket site now and select your blog repository. From there, you can see the overview of when the various commits have occurred. You can look at the source code, and you can see that all of the source code from the application is now stored at Bitbucket, and you can look at the commits that have been performed as well. This completes the 6th lecture in Module 2, as well as the module as a whole.